Hi friends, welcome back to our channel Physics Tutorial. Today we are going to continue with the discussion of 7th chapter of plus 2 physics, that is alternating current. So in the last class we had discussed the basic ideas of alternating current, then AC applied to a resistor. So today we can move to the continuation of that is AC applied to a capacitor and inductor. So are you ready? Now we have AC applied to a capacitor. So here we can see that the circuit is containing a capacitor having capacitance C and which is connected to an alternating voltage V is equal to Vm sin omega t. Then the current will be flowing through this. Okay, now here we have to study the 5 points that we have already discussed in the last class. So the similar steps we are following in all the cases. So in the case of resistor, capacitor, inductor, then LCR circuit, in all these cases we will be continuing with the same steps. So that I will just remind you now, that is the current we have to find. Here we have the relation for voltage, so corresponding current equation we will find, then relation between V and I, voltage and current, then graph we have to draw, then phasor diagram, then average power. So these are the 5 points that we are going to discuss here also. So first of all we can start with the current equation. So how we can find the current, instantaneous current in the case of AC applied to a capacitor. Here we have a circuit which has a instantaneous voltage V is equal to Vm sin omega t. Here Vm is the peak value of voltage. Okay, now we have to find the current. So how we can find current? So here only capacitor is there. Then how we can find current? Current I is equal to dq by dt. Right, so Q we have to find. So in the case of capacitor, C is equal to Q by V. That equation we have already told. Right, so Q is equal to C into V. Q is C into V. Now, how we can find current? That is, instead of V, we can substitute the equation V is equal to Vm sin omega t. Then, what will be the equation? Q is equal to C into Vm sin omega t. Okay, so that is the equation for Q. Now, we have to find the current, that is I is equal to dq by dt. Then that is d by dt of Q is C Vm sin omega t. So, C Vm sin omega t we have to differentiate. Then the constants we can take outside. What are the constants coming here? Yes, C, that is the capacitance. Then Vm is the peak value of voltage. So that we can take outside. Then what we will get? C Vm d by dt of sin omega t. What is the derivative of sin omega t? That is cos omega t into omega. So the equation becomes C into Vm into cos omega t into omega. Clear? Now we can rearrange it. Then how we can write? C omega Vm cos omega t. C omega Vm cos omega t. That is the equation. So current can be written as I is equal to C omega Vm cos omega t. So this can be taken as the second equation. Now we can see the first means the voltage was Vm sin omega t, but here we have in terms of cosine. Okay, cos omega t as a function of cos. So we can't compare these two easily. So what we have to do is, here this current, that equation of current we have to convert in terms of sine. Okay, so for that we have the equation sin pi by 2 plus theta is equal to cos theta. That we have studied, right? So sin pi by 2 plus theta is equal to cos theta. That means here instead of cos omega t we can substitute sin pi by 2 plus omega t. Clear? So what will be the equation? I is equal to C omega Vm into sin pi by 2 plus omega t. Pi by 2 plus omega t we can write. Clear? Now here we can just rearrange this equation. That is, this is in the form of sin omega t. Okay, so we can write it as sin omega t plus pi by 2. So the equation for current is I is equal to C omega Vm into sin omega t plus pi by 2. So this can be written as the third equation. Now we have C omega Vm. Here we have Vm. Okay, so when we compare these two, here we can see that this is the current. So I is equal to Im sin omega t, right? So instead of Im we have C omega Vm. So this is the peak value of current. So C omega Vm is the peak value of current, and here how we will write Im, actually current equation for current, how we can write Im is equal to Vm by R, right? Vm by R. So here we have Im is equal to Vm divided by what will come instead of R, resistance. Yes, that is 1 by C omega. So here we can write the equation Im is equal to Vm by 1 by C omega. So this 1 by C omega is very important thing, that is the capacitive reactance. So instead of resistance, here we have capacitance, right? So here that value capacitive reactance is given by 1 by C omega, that can be written as X into C, XC. Okay, that is a capacitive reactance. So if we substitute that equation, what we will get? Im is equal to Vm by Xc. So this equation is also very important. Im is equal to Vm by Xc. Then how we can write I is equal to Im sine omega t plus pi by 2. Sine omega t plus pi by 2. So this is the fourth equation, right? So this is our fourth equation. Now we can compare. So our first point is over now. So we have found the equation for current. So this is the equation for current. I is equal to Im sine omega t plus pi by 2. Now we have to compare the two equations, that is voltage and current. So which is the equation for voltage? V is equal to Vm sine omega t, and current is Im sine omega t plus pi by 2. So what will be the difference in phase? Yes, that is pi by 2. Here which one is leading? Here current is equal to Im sine omega t plus pi by 2 is there. That means the current leads the voltage by an amount pi by 2. Okay, or by a phase pi by 2. So that is very important. So that is the relation between current and voltage. That is, the current leads the voltage by pi by 2. So whenever we see the equation, we can understand it directly, right? So V is equal to Vm sine omega t and I is equal to Im sine omega t plus pi by 2 we are comparing. In this case, here only omega t is there, and here we have omega t plus pi by 2. So that means the current leads the voltage by an amount of pi by 2. Okay, so that the factor is pi by 2. So this is the second point. Now we have to draw the graph of these two, that is voltage and current. So we can find the values of graph now. Now we have to draw the graph of voltage and current. So we can consider the two equations. V is equal to Vm sine omega t and current I is equal to Im sine omega t plus pi by 2. So what will be the values of omega t here? So the first of all we can find the voltage and then current. So in the last case we have how we have calculated, in the same manner we have to do here also. So here how we can find voltage? So for omega t we have to give the values of 0, pi by 2, pi, 3 pi by 2 and 2 pi. The corresponding values are given here. So first of all what we will get? V is equal to Vm sine omega t. Here 0, sine 0 is 0. So the total value will be 0. Here after that pi by 2 means that is 1. So 1 into Vm. So Vm, then again pi by 2 will be, omega t will be pi, then that is 0. Then 3 pi by 2 means here what we will get? Minus 1. So minus Vm. And 2 pi means sine 2 pi, that is 0. So total will be 0. So first of all we are getting the values of V corresponding to this angles. Okay, and in the similar way we have to find the current also. So what will be the current for angle omega t means 0. So here in which equation we have to substitute? Yes, Im sine omega t plus pi by 2 is there. So that also you have to consider. So what will come here in the first case? Yes, sine omega t plus pi by 2 is there. So here sine, instead of pi by 2 omega t we can give 0. So sine pi by 2 only is coming here. Sine pi by 2 is 1, right? So 1 into Im. So that is Im. And in the second case what we will get here? Sine pi by 2 plus pi by 2. So sine pi, that is 0. So here 0 we are getting. So in a similar way we have to substitute. In the third case what we are getting? Yes, here omega t means pi plus pi by 2. So 3 pi by 2, right? So that will be minus Im. Then again 2 pi. So 2 pi plus pi by 2. Like that we are finding this, so that will be Im. So the total values we are finding here, and we can substitute in that graph. So how we will get the graph? Here we can consider the voltage or current here, V or I, and here we are taking the angle omega t. Okay, so here we have pi by 2, pi, 3 pi by 2 and 2 pi. So first of all we can draw this graph for voltage. So voltage means for 0 the value is 0 itself, right? And for pi by 2 the value is, yes, pi by 2 it is Vm, that is the maximum value of voltage. And for pi is 0, and 3 pi by 2 means, yes, minus Vm, and then for 2 pi it is 0. So we can join this to get the graph. Clear? So this was in the same case as that of a resistor. And in the next case, what will happen here? I also we have to find. So here we can see for omega t is equal to 0, that is Im, because the current leads the voltage by pi by 2. So when the when voltage is 0, that will be, yes, at pi by 2. So how we can draw? At 0 means this is at pi by 2, right? And then that means Im we have to draw here, and after that for pi by 2 what will happen? That is at 0. So when it is pi by 2, here it is 0, and for pi, yes, here what is the value? Maximum value we are getting, minus Im, and for 3 pi by 2 it is 0, and for 2 pi it is Im. Okay, so this is the maximum value here. So like this we can draw the diagram. So from the graph itself we can understand that here when the voltage is 0, the current has reached pi by 2. That means the current leads the voltage by pi by 2. Here we can see the maximum value of voltage, that is Vm over here, and here also we have Vm. And the direction we are giving with this, okay, omega t. And what about magnitude? Magnitude means I is equal to V by R, right? So that always that current will be less than voltage, right? That is why we draw the magnitude a little bit less than the voltage, because whenever we draw the current, that means that should be a little bit less than voltage. It is not compulsory to do so, but to understand that concept we draw like this. So here we can see the magnitude a little bit less than the voltage. Okay, so that is the reason here I is equal to V by R, that is the magnitude. So in this way here we can see the peak value of voltage, that is minus Vm, and this is the current. Peak value of current is shown here. Now here this is the peak value in the positive half cycle. Okay, so this is the case of a graph. Now we have the phasor diagram and average power. Now we can move to phasor diagram. So how we can represent this voltage and current in a phasor diagram? So here we have the x-axis and y-axis, and voltage and current we have to represent in the same diagram. How we will represent? Here V is equal to Vm sin omega t. So omega t is this angle. So here we can represent, this is V. This is the instantaneous value of voltage, that is V is represented like this, and the angle between this is omega t. That much is enough. And here we can draw, this is the maximum value of, yes, this is the maximum value Vm sin omega t here we are getting. And what about current? Current is I is equal to Im sin omega t plus pi by 2. So omega t means this much is omega t. So this you have to understand clearly. Here we have omega t. That means for voltage we have a phase angle of omega t, and for current omega t plus pi by 2 we have to move. So here this is moving like this, right? So here after reaching this omega t we have to take 90 again, that means pi by 2. So here when we take this has moved pi by 2. So this angle in between we have 90 degree. Right, so that means the total angle is here from this to this, that is omega t plus, here this phi is pi by 2. So omega t plus pi by 2 is this. So here we can write current I, that will be equal to Im sin omega t plus pi by 2. Clear? So in this way we have to draw the phasor diagram. In the last case we have seen that the voltage and current were in phase, right? So in such a case we have drawn the same line, the voltage and current in the same line like this, okay. But now here the voltage means this is the angle is omega t, but the current leads the voltage by pi by 2. So after this omega t we have to take 90 degree again, that is pi by 2 has moved. So like this it will rotate. It has the ability to rotate 2 pi radians. Okay, so that is the phasor diagram. You have to just understand that, then it will be very easy to do for all these cases. Now we have to find the instantaneous power. This is the last case of a capacitor. So how we can find the instantaneous power? P is equal to I into V. Equations of I and V we have to substitute. So what we will get, P is equal to I is Im sin omega t plus pi by 2 into V, Vm sin omega t. So P is equal to the average value of power we have to find. So average value or instantaneous value of power means that we have to take the average of all this equation. So we can take the average of Im sin omega t plus pi by 2 into Vm sin omega t. And this is the average. Here we are taking the average of this. Here we have studied that the average value of sin omega t is equal to 0. That we have already discussed in the last class. Average value of sin omega t is equal to 0 means what will be the, here we are getting the value as 0, right? So what about the whole term? So 0 into this term means the total will be 0, right? So Im sin omega t plus pi by 2 into 0 means that will be 0 itself. So the average value of power is equal to 0. So this is called wattless current. So here we can see that the average value of power is 0 in the case of a capacitor. So this is all about AC applied to a capacitor. Now we have to discuss one more thing, that is AC applied to an inductor. So now we can find all the 5 points in the same way. Now we have to discuss the third case, that is the AC applied to an inductor. So here we are considering a circuit containing an inductor having inductance L, okay, and the applied voltage is V is equal to Vm sin omega t and the current I is flowing through the circuit. Now we can write the instantaneous voltage as V is equal to Vm sin omega t. That is the first equation. And when the alternating current is passing through the coil and an induced EMF will be produced here. That is, in the case of an inductor, an induced EMF will be produced, and that we can find by using this Kirchhoff rule. Okay, so we can write it as V minus L into di by dt is equal to 0. Here the first case we have to find the current. Okay, so for that we are rearranging this equation, that is the equation V minus L into di by dt is equal to 0. So when we rearrange this, we can find the value of current. So our first step is to find the current. So how we can find here, L into di by dt will be equal to V. Okay, so what will be di by dt? So that is equal to V by L. Then what about di, that is V by L into dt? We can just cross multiply here. Then what about I? If di is equal to V by L into di by dt, sorry, into V by L into dt, what will be I? That will be integral di, right? So integral of, instead of V we can write Vm sin omega t then into dt divided by L. So here we have to integrate for getting the total current I. So how we can write this, Vm by L is a constant that we can take outside and we have to integrate sin omega t dt. So what is the integral of sin omega t dt? Sin omega t means minus cos omega t divided by omega. So this is the value of integral sin omega t dt, that is minus cos omega t by omega. So how we can write Vm by L into minus cos omega t by omega. Now Vm by L omega into minus cos omega t. So here we can see a constant, that this can also be written as I is equal to V by R, right? So here R means this L omega. So this L omega is called inductive reactance. So how we can write the equation? I is equal to Vm by, this is XL. So that is Im, that is the maximum value of current or the peak value of current. So how we can write I is equal to Im into minus cos omega t, and this is the peak value. Now we have two equations. This is the second equation, and now we can compare these two equations. So here we have V is equal to Vm sin omega t, and here Im into minus cos omega t. So we have to convert this minus cos omega t in terms of sine. So how we can write minus cos omega t? Sin pi by 2 minus theta is cos theta. Right, sin pi by 2 minus theta is cos theta. So we have to find minus cos theta. So what will be the equation? Here sin theta minus pi by 2 will be equal to minus cos theta. So here instead of writing minus cos omega t, we can write it as sin omega t minus pi by 2. If you have any doubts in this, you can just refer the equations. Here sin pi by 2 minus theta is equal to cos theta. Then sin theta minus pi by 2 will be equal to minus cos theta. So that equation we are writing here. Instead of theta, we have omega t. Then sin omega t minus pi by 2 we are getting. So that is the equation for current. That is third equation. I is equal to Im sin omega t minus pi by 2. And now we can compare the two equations. V is equal to Vm sin omega t and I is equal to Im sin omega t. So what will be the relation between these two? Yes, here we can see that the current lags behind the voltage by an amount pi by 2. So here we can say that the current lags behind the voltage by pi by 2, by a phase of pi by 2. So that is very important point that you have to remember. So in the last case, that means in the case of capacitors, the current was leading by an amount pi by 2, and in the case of resistor, they were in phase. So pi by 2 and angle were omega t only. Right. So these points you have to remember. So how we can find the current in the case of an inductor? Here we are considering V is equal to Vm sin omega t. Right. And here due to the applied voltage here, there will be an induced EMF in the inductor. So that can be found by using Kirchhoff's voltage law, that is V minus L into di by dt is equal to 0. So what we will get here, L into di by dt is equal to V. Here we have to find the value of current. For that we will rearrange this to get the value of di. So di will be equal to V by L into dt. Okay, we can just rearrange it. Then integral di will be equal to integral Vm sin omega t dt by L. Here V is equal to Vm sin omega t, we are just giving. Then what about the value of sin omega t dt, that is minus cos omega t by omega. So Vm by L into minus cos omega t by omega, that means Vm by L omega into minus cos omega t. This L omega is called inductive reactance. That is also very important. L omega is called inductive reactance, and the equation becomes I is equal to Im into minus cos omega t. And this minus cos omega t we have to convert in terms of sine. So sine pi by 2 minus theta is equal to cos theta. So sine theta minus pi by 2 will be equal to minus cos theta. So that we are applying here. So I can be written as Im sine omega t minus pi by 2. So that means the current lags the voltage by an amount of pi by 2 phase. Okay, so that is all about the relation between V and I. Now we have to complete the graph, then phasor diagram, then average power of this inductor. Clear? Now we have to discuss the third point, that is the graph between voltage and current. So here we have the voltage, that is V is equal to Vm sin omega t, and I is equal to Im sin omega t minus pi by 2. Here we have already told that current will be lagging behind the voltage by a phase pi by 2. So when we draw the diagram, we can easily understand that. So the voltage will be the same. Okay, so when it is 0, that means the angle is 0, means the voltage will be 0, then it reaches maximum, then 0, then again maximum in the reverse direction, like that. Okay, so that will be the same, and what happens is that the current will be lagging behind. When it was leading means we have started from here and it will be going like this. So here leads means when it reaches 0, that means when the voltage reaches 0, the current will be in negative. So that will be negative. So also we can see that in all points there will be a phase difference between voltage and current as pi by 2. So that lagging of current can be seen everywhere in the diagram. Okay, so that is the graph, and now we have to draw the phasor diagram. So phasor diagram means here we have to draw that voltage and current in the same graph. So here we can see this is the this is horizontal, here we are taking the vertical, and from here we will start moving. Okay, this is 0. Okay, so from 0 it starts to move. So here we have V is equal to Vm sin omega t. So first of all we can draw the diagram, that means the phasor of voltage, that is Vm, that is the maximum voltage. So the angle between that is omega t. Here we can see omega t is the angle between voltage. Okay, so that means Vm. So here from 0 to Vm, the it rotates, the omega t will rotate from 0 to Vm. So this is the angle for velocity, and the maximum value is here, V is equal to Vm sin omega t. So this is the case of voltage. So Vm sin omega t can be drawn here, and now we have to mark this current. So what about current? Im sin omega t minus pi by 2 is there. So there should be a phase difference of pi by 2. That means this pi by 2 lag is there in current. Okay, that means the current lags the voltage by pi by 2. So here the Vm is here, right? So there should be a difference of 90 degree between this current and voltage, that is also behind that. So here we can see that this is 0, and from 0 it has moved to this much. Okay, so when we take the current, we can draw the current over here. So the phasor of the current is here, because here there is a difference of pi by 2. So that this is negative, right? So this is before 0. That means here it will be rotating like this to get that 2 pi. So here we start from here, means this should be, that means here if we have reached the voltage, means the current will be behind that by an angle pi by 2. So here we can draw the current Im, maximum value of current is here, and this magnitude is shown here, Im sin omega t minus pi by 2 is here. This is the case. And that thing you have to understand here, the omega t is coming in between the 0 and Vm, and the value of current, maximum value of current is shown here. Okay, so that is the phasor diagram. Now we have one more thing, that is average power. So how we can find the average power? Average power P is equal to V into I. That is simply we have to substitute the equations. V is Vm sin omega t and I is Im sin omega t minus pi by 2. So that equation we can substitute here. Then what we will get? P is equal to Vm into Im sin omega t into sin omega t minus pi by 2. So here we have to take the average value. So what about the average value? Average power can be taken as by taking the average of this. So average of Vm Im sin omega t into sin omega t minus pi by 2. And the one more thing that you have to remember is average value of sin omega t is equal to 0. Right, so that value we can substitute here. So here we can write it as the Vm sin omega t and Im sin omega t minus pi by 2. So that average we have to take separately, right? Then we have to multiply with that. Then what we will get? Sin omega t is 0 means sin omega t into sin omega t minus pi by 2. That means it is 0 itself. That is the average power in case of an inductor. That is also 0. So in the last case we have discussed that in the case of a capacitor also the average power was getting as 0, and before that there was a power, so that we have calculated, right? Now we can conclude the video by giving all the three, that means resistor, capacitor and inductor into a frame. That means we can compare the equations and all the details of resistor, capacitor and inductor. Then we can conclude the video. Clear? Now we can have a quick review of all the three components, that is resistor, capacitor and inductor. When they are connected to an AC circuit, what will happen? So all the points we can just review here. That is voltage will be V is equal to Vm sin omega t, and in the case of capacitor V is equal to Vm sin omega t, and in the case of inductor also we have the same voltage, that is V is equal to Vm sin omega t. So all the three are having the same voltage. And what about current? In the case of resistor, the current will be I is equal to Im sin omega t. Okay, and I is equal to Im sin omega t, and in the case of capacitor, I is equal to Im sin omega t plus pi by 2. I is equal to Im sin omega t plus pi by 2. That means the current leads the voltage by pi by 2. And in the case of inductor, we can see that I is equal to Im sin omega t minus pi by 2. I is equal to Im sin omega t minus pi by 2. And what about Im? How we can calculate Im in resistor? Im is equal to Vm by R. Here we used Ohm's law. Right, here in the case of capacitor, Im is equal to Vm by Xc. Xc is the capacitive reactance and its value is 1 by C omega. X is equal to 1 by C omega. And in the case of inductor, Im is equal to Vm by XL. And XL is inductive reactance, that is L omega. Right, and in the relation between V and I in the case of resistor is V and I, that is voltage and current were in same phase. And in the case of capacitor, in the case of resistors, the voltage and current are in same phase. And in the case of capacitor, current leads voltage by pi by 2. Current leads voltage means current I is equal to Im sin omega t plus pi by 2. That is why current leads the voltage by pi by 2. And in the case of inductor, current lags behind voltage by pi by 2. So current will be lagging behind the voltage by an amount pi by 2. So here I is equal to Im sin omega t minus pi by 2. Now we have the phasor diagram. So when we look into the resistor, here we can see here voltage and current are in same phase, right? So we can draw both in the same line. So here the angle is omega t for both current and voltage. But here the current leads by pi by 2 means here we have omega t, that means Vm is here plus pi by 2 is there. So this is pi by 2. So here current Im will be coming here. Okay, and in the case of inductor, current lags behind pi by 2. So here we have the voltage Vm, omega t is here, and that will be lagging. Here the current will be lagging by an amount pi by 2. So this difference is 90 or pi by 2. So that is how we can draw the phasor diagram of resistor, capacitor and inductor. So this is all about the AC applied to a resistor, capacitor and inductor. Now we have to discuss LCR circuit. So all the three will be connected in a single circuit, and that we can discuss in the next class. Hope it is clear to you. Now we can conclude the video. If you like the video, please like, share and subscribe. Thanks for watching.